What is poppin', everybody? Man, I'm back. I'm back. Had a couple of days off, but that's okay because we're back and we're getting it. If you do things in life halfway, you're gonna live life halfway. I don't care if you're doing a Git tutorial. I don't care if you're eating a quarter pounder from McDonald's. You better eat that cheeseburger all the way, because if you don't, you end up living life halfway. With that being said, we are back here with the Git tutorial looking at W3 schools. Um, I say the same thing on the start of all of my videos. If you're looking to learn Git, GitHub, stop watching this video, go create your own video, go read your own book, go make your own project. Because at the end of the day, we are our own best teachers. Making these videos is predominantly for me to keep me accountable every single day, learning a little bit more, and then keep track of my work history. I got version control with YouTube for my work history, but ultimately, I feel like we are our own best teachers. So with that being said, let's jump into Git undo. We got Git revert, Git reset, Git amend. And then ultimately we will be done with the W3 Schools course, but we will not be done with Git and GitHub. Still got a lot of work to do to understand the complete picture. All right, so revert is the command we use when we want to take a previous commit and add it as a new commit, keeping the log intact. Find the previous commit. We find the previous commit, use it to make a new commit. Okay, simple enough. Find the previous commit, use it to make a new commit. Let's make a new commit where we have accidentally deleted a file. Okay. Git commit, just a regular update, definitely no accidents here. Okay. Now we have a part in our commit history. We're going to go back to, let's try and do that with revert. Okay, so let's go into git bash. Let's ls and go into our OneDrive, cd1 drive. We'll go ls. Do we have documents? Let's go actually back up because I did this. I think it was in K9. We went to the documents folder within K9, I believe. So we'll cd documents. Then we'll cd into projects, which I already know is in documents with ls. And which one were we doing? W3 Schools clone, Git project merge, Git practice. Which one were we on? I guess we can really pick any. Which ones are on my GitHub? Read those. Created that. Git flow testing. Is that it? Git flow testing. All right, we're gonna go with Git flow testing. Do we even have that? We don't even have that. Okay, so I think that was for something else. Git flow testing. Let's see what that has in it. It has an index.html, which has nothing in it. So let's go cd git project merge ls. That's not it. We'll go back up. ls cd git practice. Will that work? Alright, so git practice. So let's see what's in git practice. We have our index.html. Let's open that index.html and see. Hopefully there's nothing in there. There's not. So this probably is the GitHub repository, the equivalent of the GitHub repository. Let's go git branch -a. Remote origin main. Let's see. Okay. So I'm assuming that this is the same branch. How do we ultimately tell if two branches are synced up? How do we tell if a local repo and GitHub repo are synced together with Git? In the corresponding repository synchronized, you can use several Git commands and steps to check their status. How do we know if the names aren't the same, that two repositories are each other's equivalent with respect to local and remote repos? Would we just look at the files within and determine, or what? Because there can be different repos with the same files. So for example, I have a git flow testing. For example, I have a git flow testing remote repo and a git practice repo, both of which only have one index.html file that is blank. How do I know that these two repos correspond with each other? All right. Okay. To determine if your local repo and the corresponding remote repository and GitHub are synchronized, you can use several Git commands and steps to check their status. Here are some common methods to achieve this. Fetch the latest changes from remote. First, fetch the latest changes from the remote repository without merging them into your local branch. This will update your remote tracking branches. Git fetch origin. Alright, let's do that. Clear git fetch origin. Okay. Compare local and remote branches. After fetching, you can compare your local branch with the remote branch. So actually, let's make a change in this. In the index.html file. Let's just edit this file. Let's go ahead and just create a paragraph tab. Let's go testing to see if repos are linked. Okay, commit changes. Date. Just updating index.html to see if repos are linked. I mean, not LinkedIn, linked. Ooh, commit email. Yeah, okay, cool. Commit. And now we are going to git fetch. So this should show up in our git flow testing. Now we're going to go git fetch origin again. Git fetch origin. Alright, so it actually did something this time. Okay. So now compare local and remote branches after fetching. Git log. After fetching, you can compare your local branch, master man, with the remote branch. We go git log, one line, head, origin, main. This command will show if there are any new commits in the remote branch that you don't have locally. If nothing is returned, it means there are no new commits on the remote branch that you haven't pulled yet. Okay, so we got git log, one line, head, origin, /main. So we go git log, one line, head, origin /main. Is that correct? It is. Run. So it does update index.html. It's showing. Check for local commits that aren't pushed yet. Okay, so let's look at let's go to the index.html. We're gonna say local commits that aren't pushed yet. So we'll create that. We'll create a new checking to see if there are local commits that haven't been pushed yet. Okay. And now we will go back to Git and we will go git log one line and we'll go origin /main head. Huh. I feel like that should be returning something. What if we did all capital head? Still nothing. Did we save? Saved. Index ls. Okay. Git status. Modified index.html. We have not. Oh, okay. So we haven't set it to the staging area. So we'll go ahead and do that. We'll just say git index.html, and we'll go git commit message adding change in index.html to see if remote branch matches up with local. Okay, now we will go git log dash dash one line origin slash main dot dot head, and now we will see that there is a file that doesn't match up with main. Okay. Alright, this will list commits that are in your local branch, but not in the remote branch. If there are no results, it means all your local changes have been pushed. Alright, status of branches. Ultimately, though, I wanted to find out if the two branches were synced. We know that they are now, but how would I be able to tell? Like, by synced, I mean that, because they're different names. I'm sure it'll answer that below. To get a summary of the current branch and its tracking branch, you get status. So we should see a clean working tree with get status as we have pushed. We'll go get status. We have committed, staged, and committed all of our changes. Your branch and origin main have diverged and have one and one different commits each respectively. Use git full if you want to integrate the remote branch with yours. Okay, so but ultimately nothing to commit. We're working on a clean tree. This command will inform you if your branch is ahead, behind, or has diverged from the remote branch. If it is behind, it means there are changes in the remote repository that you need to pull. If it's ahead, you have commits that need to be pushed to the remote repository. Difference in branches. If you want to see the differences between local and remote branches explicitly, git diff master origin main. So right now we're on the main branch, so we can do git diff main origin master. Hold on. I guess git diff main, and then which is our local main branch that we're also git diff main, and then ultimately we want to see if there are changes that need to be made between branches with origin slash main. Alright, so shows a slash index.html, b slash index.html, p checking to see, and then it shows our updated index.html in the remote repo using git diff, and looking at the difference between the branches. Git diff master, origin master, replace master with your branch name if it's different. This command shows actual line-by-line differences using git branch dash or vv. This command shows that the last commit on each branch and the status relative to the remote branch. This command shows the last commit on each branch and the status relative to the remote branch. Alright, we'll try it out. Git branch dash vv. Origin main ahead one, behind one, adding change index to HTML to see if the remote branch matches up with the local. Okay, cool. Look for indications in the output such as ahead one, behind two, which tell you how many commits your branch is ahead or behind of the remote branch. These tools and commands will help you access the synchronization status between your local and remote repositories effectively. Okay, so ultimately, how do we know? Okay, so we asked that question, if the names aren't the same, that the two repositories are each other's equivalent with respect to local and remote repos. Will we just look at the files within and determine, or what? Because there can be different repos with the same files. For example, I have a git flow testing remote repo and a git practice repo, both of which only have one index.html file that is blank. How do I know that these two repos correspond with each other? When the names of the local or remote repositories are different and the file structures or contents are not distinct enough to set them apart, determining if they correspond to each other can be more challenging, okay? Let me read that again. When the names of the local and remote repositories are different and the file structures or contents are not distinct enough to set them apart, determining if they correspond to each other can be more challenging. Here are a few methods you can use to verify if two repositories are intended to be equivalents or are related. Alright, so check the Git remote configuration, Git remote-v. The most direct way to identify if a local repository corresponds to a specific remote repository is by examining the remote configuration and the local repository. So we go git remote-v. This command will display the URLs associated with each remote repository configured in your local repo. If the local repo, Git practice in your case, lists a remote pointing to the Git flow testing repository on a platform like GitHub, this indicates that they are intended to be connected. That's what I needed. So we go git remote-v. And so we have two origins. We have an SSH origin and we have a HTTPS origin. Before, how to copy and git bash. Okay, two questions. How to copy with keyboard and git bash. I'm just gonna git bash. And then what if I have git remote-v What if I have git remote-v and fetch and push URLs come up for both HTTPS and secure shell protocol? Final question, while it's on my mind, what are lists used for in C#? To my understanding, it's basically like an array that maintains data types. Right. We'll go back up. So we got git remote-v, commit history. Even if the repos have similar or identical files, the commit histories might give you more context. Even if remote repositories have different or identical files, so commit histories might give you more context. We go git log -1 line. Run this command in both repositories to review their commit messages and hashes. If the repositories are meant to be mirrors or equivalents, the commit histories will generally align closely unless one has received updates that the other hasn't. Git log -1 line. Git log -1 line. Alright, so we can see the commit history here. This one was done in the remote repo. This one was done in the local repo. And branch comparisons. Particular branches in each repository can provide clues about the relationship. Get branch-a. So That's origin main. Git branch has A, which is what I did originally. I get main and which is in green, and then remote origin main, which is in red. Why wouldn't it just be origin? I'm assuming the red is pointing towards the origin. Be back. Alright, configuration files and documentation. Sometimes repositories meant to be connected will have documentation and configuration files that reference each other. It could be in the form of README files, setup scripts, or deployment configurations that indicate how repositories interact and are intended to be used so that ultimately we know that the remote and local repositories are each other's counterparts, but we're just figuring out how to do that more, how to find that out more efficiently. If available, metadata such as repositories, descriptions like GitHub, GitLab, or allow hosts might indicate a relationship. This could include explicit mentions of each other, descriptions that imply shared purpose or usage, file signatures, and content. While both repositories might contain an index.html that's blank, more complex projects usually have distinguishing features and other files. Okay, look at scripts, configuration files. So just to avoid headaches, I feel like it's important to always name your remote repo exactly what your local repo is called. Okay, so 2 questions. Copying with keyword in Git Bash. In Git Bash, copy and pasting can sometimes be differently depending on your system configuration or terminal settings. Here are common methods. Use a mouse. Nope. Windows. Usually, Control Insert is used for copying, and Shift Insert for pasting. You might use Control C for copying if it's configured not to send an interrupt signal. Alright, multiple URLs. Alright, when you run git remote-b and see both HTTPS and SSH URLs for fetch and push, it indicates that your local repository is configured to interact with it. Your local repository is configured to interact with the remote repository using both protocols. This configuration might look something like this, and that's what we saw. The setup isn't typical because usually a single URL is used for both fetching and pushing. However, it's possible to configure multiple URLs for different purposes. HTTPS is widely used due to its ease of setup and use of firewalls. SSH, Secure Shell Protocol, is preferred for security features and because it doesn't require you entering your username and password frequently. If you see both, it might be a configuration mistake. We just did that for the purposes of the project, or you might have specific workflows that require both. You can standardize on one by setting the remote URL. Git remote set origin URL. You can standardize on one by setting the remote URL. Remote set URL origin. Okay, replace URL with either the HTTPS or SSH URL depending on your preference. List of T is indeed similar to an array, but with many added advantages. It's part of the system.collection generic namespace. It's a generic type and provides a way to create a strongly typed list of objects. Here are some key features. Dynamic sizing, unlike arrays. List of T automatically resizes as you add or remove items. Type safety. List of T is generic, which means it can store any type of data. If you benefit from type checking at compile time, provides methods for searching, sorting, and manipulating lists which are not available in arrays without additional coding. Essentially, List of T is used in scenarios where you need a collection that can grow and shrink dynamically while maintaining strong type safety, unlike arrays which have a fixed size and require manual handling to resize. All right, and then our final question. All right, now let's get to work. Okay. Git commit. So let's commit. First of all, let's push and pull to sync our two remote repositories. So we'll go git push. I think we already set it up at the upstream, so we can just do git push. Git flow testing dot git. All right, what if we did git pull? All right, merge conflict and index.html. All right. So I want to keep both. Okay. Okay, is there anything to add? Okay. Git commit -m updating changes from repo. Now we're gonna go git status. Your branch is ahead of word remain by 2 commits. So let's go git push. Alright, should be up there. Refresh, look at our index. We should have 2 lines. We do. So we're in sync now. So let's go ahead on our local, make another change to our index.html file. We'll just go adding another line to work on revert, git revert, revert. And then before we do that, we will clear and go whew. Alright, so we are going to git commit, just a regular update, no actions here. So let's go git add dash all lf working copy of index.html. Next time git touches it. Insert, control insert. What does this mean? What does this mean? And it's informing you about how it will handle these differences in your file. Understanding line endings, using line endings. Alright, what this is, true. Okay, so we should be good. And we're just going to go ahead. Did we already commit? Did not go commit dash m. You know, let's do this. Just a regular update. Definitely no actions here. Right. Now we have a part of our commit history we want to go back on. Let's try and do that with the revert. Git revert find commit in log. First thing, we need to find the point that we want to return to. To do that, we need to go through the log using git log. To avoid the very long log list, we're going to use the one line option, which gives just one line per commit, showing the first 7 characters. Okay, hold on. We're going to use a git one line option, which gives just one line per commit showing the first 7 characters of the commit hash and the commit message. So let's find the point where we want to revert. So we'll go git log one line. Here we want to revert to the previous commit 524.8f7, and we see that it is the latest commit. So we will do the same thing. Git log dash dash one line. Log dash dash one line. Just regular update, definitely no accidents here. Updating changes from remote repo. Okay. We see that it's our last change, git revert head. We revert the latest commit using revert head. Revert the latest changes, change, and then commit, adding the option no edit to skip the commit message editor, getting the default revert message. So we go git revert head dash dash no edit. Now let's check that log again. So it has our initial commit, but it basically commits a commit of our commit, which doesn't now have our commit, basically. Git revert dash dash head. Was it dash dash head dash no edit? No, head. Git revert head dash dash no edit. Git revert head dash dash no edit. Alright, now we're going to go back to our git log dash dash one line, and we will see our original commit, and we will see our commit that reverts the original commit. So ultimately, so just me making sense of this, ultimately git revert commits a new screenshot of the project without the other commit. So it's committing a commit that basically says another commit should not have happened. So ultimately, does the code go back to the state directly before that particular commit happened? So if I get reverted a commit that happened 5 commits ago, would the get revert commit point back to the state of the code 5 commits ago? Okay. What get revert does get revert is used to undo changes made by a past commit by creating a new commit that reverses the changes. Get content revert does not modify the existing history. Instead, it appends a new commit to the current history, which effectively negates the changes to the previous commit. Okay. So why wouldn't you just? So what's the purpose of that? Why wouldn't you just? If you needed to backtrack, why wouldn't you just go to the commit before that commit? The purpose of this. Why wouldn't you just backtrack and go to the commit before the commit you're trying to revert? Concise. Which alter the commit history, get content revert, does not modify the existing history. Instead, it appends a new commit to the current history, which effectively negates the changes of a previous commit. Okay? How it works. When you execute get revert on a specific commit, Git calculates the differences that the commit introduces and applies the inverse of those changes. This inverse is then committed to a new commit. This approach is safe for shared repositories because it preserves a commit history, avoiding the potential issues that arise from rewriting history that others may have based on, that other people's code may have been based on. Reverting a commit that happened 5 commits ago. Git does not revert all commits up to that point. Instead, it only reverses the changes made by that specific commit. I feel like that's something that I'm going to have to encounter in a project to really appreciate. The new commit contains the inverse of the changes from the commit you targeted. This means if that commit added a line, the revert commit removes it, and the commit removed the line, the revert commit adds it back. The rest of your project remains unaffected by other changes that occurred in the commits after the one you reverted. Suppose your commit history looks like this: commit A, commit B, C, D, E. If you run git revert C, Git creates a new commit, let's call it commit F, that undoes the changes introduced in commit C. The project state after commit F will reflect all the changes from A, B, D, and E, but without the changes from C. Oh my gosh, I forgot I was doing this. Okay. We are going to finish it up real quick. I'm going to pause this. God, how did I lose track of time so easily? Pause this, stop the video, create a new video. Actually, let's just power through. Something completely unexpected came up on my phone, so I was kind of drawn into that. So Git revert, we have a good idea of Git revert. So let's finish Git revert before we close shop today. It's the latest commit using Git revert head, revert the latest change, and then commit, adding the option no edit to skip the commit message editor, getting the default revert message. Okay, we see that, we did that. To revert to earlier commits, use git revert head (x), x being a number, 1 going back 1 more, 2 going back 2 more, etc. Interesting, okay. On the next page, we'll go over git reset, which brings the repository back to an earlier state in the commits without making a new commit. On the next page, we'll go over git reset, which brings the repository back to an earlier state in the commits without making a new commit. Okay, so show the log of the repository, showing just 1 line per commit. We'll go submit answer dash 1 line. Submit. Revert the latest commit. So we'll go git revert. Last. No. Git revert. What was it? Dash. All. Dash. Oh, what was it? Revert the latest commit. Oh, it's using the tilde index. So we got 1. Is that? Revert the latest. Git revert head. Git revert head. We're skipping the commit message editor, so we'll go dash no dash edit. Actually, I believe it was dash no dash edit. Revert the last 2 commits, so we'll go git revert head 1. No, what was it? tilde, and then the number of commits you want to revert to. Revert head tilde, and then we're going to go last two, last one. So get head is the so it kind of abides by the array syntax. So okay, ultimately today went a little overboard, got sidetracked with something that happened. Learned a little bit about git revert, why it's important. I feel like ultimately I won't be able to appreciate it until I use it in a project, which is what we're going to end up doing in a couple of days. Yeah, so that wraps up today's session of Git, and I'm out of here. See y'all. Take care.